Today's webinar is about big data and its impact on marketing. I'm Kaiser Fung. The following materials represent my own opinions and not those of Vimeo. We hear big data as a big buzzword these days, and if you go read the newspaper, pretty much every week you're going to find all kinds of articles about big data. If you talk to 10 people about big data, you'll find 10 different definitions of big data. So I'm going to first start by defining what I mean by big data. The big data, the first half of it is big. And what we mean by big is that the data set is large. And technically speaking, there are really two sides to big. We call this big P and big N. Big P represents the width of a data set. That's really the variables that are in there, the types of behaviors that we are able to track these days, and the kinds of data that we can collect about people. The other side of big is big N. Big N represents the number of rows in the data set, and rows typically refers to customers or users or people. So what is changing is that both P and N are increasing in a very rapid rate, and these effects actually multiply. So we have exploding amounts of data. The second part of big data is the data itself. Data comes in many new types, and we're now able to analyze things that we don't used to analyze. So chief among this is text data that comes from the call centers or surveys and so on. And this is what we mean when we use the word unstructured data. A different kind of data is data from web logs that records events and transactions. A third type of new data is stuff that comes in networks. So the most famous example of this is the Open Graph by Facebook, which is basically a network of how people are linked to other people. Thinking backwards, Google's PageRank algorithm is really based off of a network as well. That's the network of hyperlinks, which is how web pages are linked to each other. And the last part of new types of data is all the things that we couldn't imagine even 10 years ago that we would be doing today online. Things like clicking on the Facebook like button, tweeting, retweeting, sharing videos and stuff online. All those contribute to new data being collected. So the amount of data and the types of data are the two most important characteristics that everyone typically will point to when they talk about big data. There are actually two other even more important features of big data that I am particularly interested in. One is the Moneyball culture. So one of the most important things that have happened in the recent past with the rise of the big data era is that a lot of business managers are willing to consider data and incorporate that into the decision-making process. Moneyball was the book written by Michael Lewis that was later made into a movie starring Brad Pitt. This charts the rise of the Oakland A's franchise in Major League Baseball. The Oakland A's is a very small market team, and they were able to compete with some of the very large, heavily funded big city teams because they hired a bunch of data jockeys who were able to process all of the data to come up with good players that they acquired. One of the central tensions in Moneyball is this notion of the old school baseball scouts who rely on the expertise and the intuition to make decisions versus the new school data jockeys who rely on statistics and data. What you will find is that good data analysis actually requires a lot of intuition. So really intuition and data are not opposing, they are complementary. That's actually one of the underlying themes in my new book, Number Sense, uh, where you'll find that intuition plays a major role in any kind of data analysis. The other thing that is not often mentioned, but is also very important in the big data era, is that it's not the amount of data, but the data is now publicly accessible. There are a lot of people who are able to access this data and be able to analyze it. One part of the accessibility is a result of the open data movement, in which a lot of governments and organizations that have been collecting data for long periods of time are now able to put the data up publicly available online. And there's a lot of interesting stuff out there if you look around. Another side to big data accessibility is the availability of very cheap or free web tools that allow us to make your own data. I actually call this MIY data, make it yourself. And the case study here is Panda Express, which is this chain of Chinese shopping mall stores, food stores, where you can get lunch. Uh, and what happens is after you buy lunch, you'll find on your receipt this section that gives you an offer. The offer says that if you go fill out an opinion survey online, you're going to be able to come back and get a free entree item for your next order. So if you go online to the website, you'll find that there's a pretty extensive customer survey, goes through multiple pages, and asks you a whole bunch of questions, about 10 to 15 in all, mostly about when you went to visit the store, the customer service, and the food quality and selection, and so on. So a lot of variable information from a marketing perspective. What is changed nowadays is that the engine powering this survey is something like a SurveyMonkey, which is a almost free sort of web service that collects and processes and displays all this information for you. So no longer does a company need to have data entry clerks or data analysts that must go and process and analyze this information. This is really something new that is happening with the big data era. So after the customer fill out the research, they're going to get a code. And this code is actually very important as well. So the code is then used to close the marketing loop. So the customer takes the code back, let's say the next day, to get another lunch. And that code will allow the customer to actually get the free entree item. What happens at that point is that code is fed back to the database. And now the marketing person will know that there's this customer who actually took this particular offer and gave us information. And you can really measure the effectiveness of your marketing activities this way. So make it yourself data is one of the very important new things to have happened recently. Now, this slide shows a conceptual overview of how the big data industry sees itself, typically. So it's almost like a factory, and there's a production process here. So the green arrows are essentially all of the user interactions, like the clicking on the page, viewing a video, hovering over something. All of these behaviors are being captured in these things that are called web logs, which are just text files. And the web logs exist inside computers that are called servers. One of the really important innovations in the big data era is that the servers are now distributed. They're not centralized. Your data is just spread out around geographically. It will end up being centralized somewhat into a data warehouse which exists at the enterprise level, because ultimately, in order to do data analysis, we do need to bring data together and look at correlations and so on. It turns out that the big data warehouse is typically too unwieldy, so different subsets of the data is now turned into things called data marts. There might be a data mart for the finance department, a data mart for the marketing department, and so on and so forth. But ultimately, the data mart is also not what is exposed to the end users. What the end users see, the business managers see, are these things called displays. Displays might be in the form of an Excel spreadsheet. It could be in the form of dashboards, data cubes. It could be a predictive model that generates some predictions. It could be a forecast. This is the way that big data exists today. When I wrote my book, Number Sense, what I really want to draw attention to is that this picture is actually missing something. It's missing something on the right side of the chart, which is the consumption of big data. Because ultimately, the dashboards and the data cubes and so on are useless unless they are able to impact things like strategies, tactics, and plans. So ultimately, the entire enterprise is how do we use the data to affect strategies, tactics, and plans. Now, there's a big difference between the left side and the right side of this chart. The left side is where we have a huge amount of scale. So there are gigabytes and terabytes and just amazing amounts of data feeding in from the left. Ultimately, for any company of moderate size, there are really only potentially dozens of strategies or tactics or plans that you might want to change from a year-to-year basis. So the big challenge of big data is really how do you harness that amount of information? How do you reduce the millions and billions and trillions of data points to a handful or a dozen actionable insights? And that's what we should be focused on going forward. Now I'm going to transition to how, as a business, can we get into the big data game, especially for those who have not done much in the data analytics area yet. I have 6 tips that I'm going to talk about today. The first is that you can start small. So despite the fact that we're talking about big data, the wise thing to do is to start at a small scale and then grow as you see benefit. And there's a reason for this. Some of you might recall back in 2007, Netflix launched the Netflix Prize, which is a competition in which they invited research scientists and other people to help them improve their internal algorithm that is used to predict movie ratings by their customers. So the 7 gentlemen on this page are mathematicians, and they ended up sharing a $1 million prize. That's a lot of money for mathematicians. And what they accomplished was a 10% improvement over the internal algorithm known as SynMatch. But what does this 10% improvement actually mean? The metric that was used was some kind of an error rate, and the SynMatch algorithm was rated at about 0.95 at the start of the competition. It turns out that if you were to do something very naive, which is simply averaging the ratings of each movie, your error rate will be about 1.05. So the difference between simple averaging and SynMatch is approximately 0.1. Then the winner of the competition, which is what I labeled 107 Ensemble here at the bottom of the chart, actually achieved an error rate of about 0.85. So what won them the competition, the 10% improvement, is really 0.1 on this error scale. And 0.1 is really interpreted as 1/10 of 1 star on that 5-star rating scale. What you actually should also notice from this chart is this very important law, the law of diminishing returns. So you'll see that going from the most simple thing, simple averages, to SynMatch was a pretty large improvement. And then all the other things um, are providing less and less marginal improvement over time. And this is a law that pretty much governs all kind of data analysis. You pretty much can get 80% of the improvement with, say, 20% effort. So that's why if you start small, you'll actually be able to get a lot of the gains anyway. And that's my first tip. The second tip is that you have to invest. So, data is not something that you can get for free. I mean, the data might be free, but the analysis is not free. There are two areas that you should invest in. One is tools. Tools are often close to free these days. There's a lot of free tools out there. There's also tools that are relatively cheap. And I'm talking about certain web tools. I'm talking about things like Excel and PowerPoint and so on. Those are pretty basic things to have. The more challenging investment item is people. And obviously Nate Silver is really expensive to get, but finding the good people is actually very difficult, and this is where you should spend a lot of time and not skim on. I usually look for three qualities when I find analysts. The first is having some math and statistics background. Second is the ability to think like a business person, basically connect the data to business metrics. The third, and to me the most important thing, is this thing called number sense, which is really the topic of my book. Just briefly speaking, number sense is sort of this intuition, sort of this intangible quality that distinguishes somebody from and makes someone able to sniff out the problems in data to really get the insights out in as efficient a way as possible. The third tip is that if you're going to get into the data game, you should think for the long run. It turns out that the accumulation of data is very powerful. So the example shown here, let's say your company just started tracking email information in January of this year. So you have now 6 months of data, and you notice the trend, and you can kind of see that from May to June, you are starting to have a problem. Your email opens have been dropping quite rapidly. If this is the only data you have, that would be your conclusion. However, imagine that if the company had actually started collecting data, say 2 years ago, then you'll be able to have a much richer analysis. So here are the lines for 2012 and 2011. If you look at this line, you might be a lot less concerned about whether your emails are performing or not, because the May to June drop could potentially be a seasonal factor. One of the things that you keep hearing is that companies need to be data-driven. My fourth tip, however, is that you don't want to be data-driven. You actually want to be results-driven. So here's a data-driven analysis. So this is Cisco looking at all of the customer feedback that they're getting. And this is a word cloud, which is a great tool to summarize the kinds of information that you are seeing from massive amounts of text information from your call centers, let's say. However, this is just data-driven, it's not results-driven, until you establish something like this. So Cisco has something called a social media response strategy, which is to use the word cloud here to generate hypotheses of what might be wrong, what are customers complaining about. Then they have field staff that is assigned to go out to validate and verify these hypotheses. And if they are verified, there are teams in the company that are asked to take action against them. So all kinds of data analysis should be tied to actual business results. You will also hear comments like some data is better than no data. I'm actually here to tell you that this is also wrong. My tip number 5 is that bad data is actually worse than no data. And one of the most important things that you always have to bear in mind is to try to make sure that the data that you're looking at is actually clean. I can give you an example of a log data. This is an event log. Basically, each row here tells you that on a certain day at a certain time, a particular user tries to upload a file or a video or something. And you can use this data set to then compute things like what's the total number of uploads per day, and you can track the trends, and you hope that this is a trend going up. Now, sometimes you encounter issues, the trends are not going as you like, and you start digging into the data, and then you might discover some things that are pretty surprising. So, for instance, you'll notice that an upload is not a simple thing. So here's an upload process map where the starting point is user clicking on a link to start upload, and then the end point is that the user is notified that the files are ready. Now, however, there are lots and lots of things that have to happen in the middle for the user to be notified. And what you don't know in a data set like this, when it just says upload, is which of these many events on this process map is being tracked. You would have assumed that what is being tracked is the very last notification. But when you dig into this, you'll notice that oftentimes the engineers have tracking on every single box here, and what you actually observe in that data set might not be that last thing. So instead of computing the total number of uploads that are successful, you might actually be computing the total of uploads that are started, and what you're missing would be all those uploads that have failed, and that would be a pretty bad thing to report back. My last tip is to keep it simple. So here's a question, a scenario that I want you to think about. A team of psychologists performed personality tests on 100 professionals, of which 30 were engineers and 70 were lawyers. Here's a brief description of one of the subjects. Jack is a 45-year-old man. He's married and has 4 children. He's generally conservative, careful, and ambitious. He shows no interest in political and social issues and spends most of his free time on his hobbies, which include home carpentry, sailing, and mathematics. The question is, what's the probability that Jack is one of the 30 engineers? You can think about it, and also if you want to put your answers into the chat, we can kind of see whether you think it's A, 10 to 40%, B, 41 to 60%, C, 61 to 80%, or D, 81 to 100%. It will turn out, and I'm seeing some answers coming in, it will turn out that according to Kahneman and Tversky, who are the behavioral psychologists who actually did this exercise back in the 70s, the correct answer is going to be A. And they're going to tell you that actually the real answer should be 30%, and they would say that that's exact. The reason for that is that the only real data point that was given to you was that 30 of the engineers are 30 out of the 100 are engineers and the others aren't. What is bothering us here is that we were given a lot of details about one person called Jack, and then we are asked to make a generalization based on that one piece of information. And what Tversky and Kahneman is arguing is that really is a one data point, and we should not be using this information to generalize to a larger population. And I'm going to leave you with this example because in the age of big data, we're going to be able to get a lot of details about individuals, and we really should be thinking twice before making our analysis super complicated, because a lot of those details may in fact not be useful to understand the general picture. Here are my 6 tips summarized again for you. And here's a screenshot of my new book, Number Sense, in which I talk a lot more about this intangible thing that you need your analysts to have. And thank you for participating today. I have my contact information on here, and I will be answering some questions if you would type it in to chat. So there's a question about privacy. Will there be a backlash because consumers nowadays are very concerned about privacy? So I have very strong feelings about privacy, and that's actually a pretty long talk by itself. But generally, I would say our industry should really pay attention to self-regulation because video, like if you think about the movie world and movie ratings, they were able to prevent the government from regulating the industry when they put out the self-regulated system. I think that there are insufficient attention to what kinds of data and how we're using the data today. And if we can self-regulate, we would be much better off. Okay, so somebody asked about how do you learn about techniques and models for analyzing data. I mean, there are actually some books out there that's actually pretty useful. I actually really enjoy a book. I think it's Barry and Ninoff. I think it's. I'm going to type it in so you can see it. Barry and Ninoff is the authors of the book. They basically give you a high-level sense of the techniques and the models without actually going into too much details of the math. I think that's a good starting point to understand the types of things that we do out there. What's the next question? Which is a more important skill for an analyst, programming skills or knowledge of statistics? I think it turns out that being an analyst, you need to be well-rounded. So it's not one thing or the other thing. I like to say I don't want to find an A+ person in one aspect. I typically am happy to find somebody who is a B+ on various different aspects of the job. So you do need to understand the basics of statistics, and you also need to have some ability to program. And having a balance of the two is better than just being good at one. There's a question from Dawn about organizational culture changes needed to adapt to the idea of big data. Absolutely. So that's where I recommend reading the Moneyball Culture, the Moneyball book. That's the Moneyball culture that you need to nurture in your company. I think the way to go about it is, like I said, to think of intuition and data as complementary as opposed to opposing. But generally speaking, one of the major jobs of anybody who's managing an analytics team is to help foster that culture change so that people are willing to consider data next to their expertise, and the end result would be a better decision. Yes, so Sergey from Canada, they have two books. This is one of those books, Data Mining Techniques. It's the name of one of them. This is the more technical one. I think they also have another book which is even less technical than this one, but either one would be a great starting point. I really think that they did a great job with that. There is a question about what are the most important marketing metrics. So marketing metrics are pretty easy. The most important, the two really important ones, one is your incremental response rate, and the other is your CPA, cost per acquisition, or cost per action. So from a response side, you want to measure Um, if you're going to spend some money, what is the actions, whether this is purchases or clicks or whatever action you want your customer to take, you want to be able to count those. You want to count it incrementally in the sense that if you didn't spend the money, you would still have a baseline level of response. So you want to subtract that out of your metric. Um, Cost per acquisition or cost per action is pretty much just taking your incremental spending and divide that by your incremental actions, and that will get you to the other important metrics, which is CPA. Then you also have a lot of subsidiary metrics that is also useful, but I don't have time to get into those right now. I think going back further, someone, I think Amelia or Amy, asked the question: is big data just hype or is it actually real? Um, the this is a difficult question because a lot of big data is hype. However, there are actual things that are real. I will give you one example of something from big data that's real. That's basically the whole online advertising space. Um, Offline advertising is really notoriously difficult to measure. However, online marketing is a lot easier to measure, mainly because we can measure a lot around like who's hovering over what, who's clicking on a banner ad or clicking on a link and so on. And all those data can be processed, and it gives us now a much better understanding of what the customer interactions are and what the customer's behaviors are. And so there's some parts of it that's not hype, but then there are lots of things that are actually hype. So you know, so that's also kind of what I get into in number sense, is to essentially give you a set of guidelines for which you can actually follow, to figure out what are the data analysis that you see out there that is just bogus and which ones are in fact credible. I think we are running out of questions here, and we're also running out of time. So I'm going to end the webinar here, and thank you all for attending. You can, if you have other questions, feel free to find me on Twitter or come to my blog.